Seventh grade lesson 7.3 is now solving two-step inequalities. Very, very similar to solving two-step equations, which we did a while back. So the steps that we have for that is if we need to distribute, then we do that. That's when we see those parentheses in there that we need to clear out. So we use that distributive property where you multiply that outer term by each of the inner terms. And then at that point, you'd probably have some terms that can combine together on the same side of the equal sign. Sometimes you'll need to do this step. Sometimes you won't need to. Sometimes it'll be already set up to go to step 2, where we use inverse operations. A reminder, operations are add, subtract, multiply, divide. Those are operations. Inverse means opposite. So we're doing the opposite operation in order to eliminate from one side, but we've got to keep the scale balanced. So we have to do the same to the other side of the equation. And we do that in order to isolate the variable, to get the variable all by himself. He does not like being with other numbers. He wants to be by himself. And then for the third step, and it's not really a step, pretty much it's just a reminder, watch out when you multiply or divide a negative number in inverse operations. Remember in lesson 7.1, it talked about how that reverses that inequality sign. If you multiply or divide across the inequality. So that's step 3 isn't really a step so much as it's a reminder. Double check that. Did you multiply or divide in your inverse operation? If so, you're flipping that inequality sign over. So keep an eye out for that. All right, in the first part of this, they say model. Model 4D minus 3 is greater than or equal to 9. Well, remember, I'm going to use the colors. The positive and negatives. Positives are yellow. Negatives are red. Variables are the bars, long bars. I'm going to do them this way, the way they did them in your book, so it's the same. These are 4 positive variables, the long bars. Then I have 3 negatives. And on the other side of the inequality, I have 9 positives. All right, there they are. And our goal, so right now we don't have the issue of parentheses or anything like that. So we're going to inverse operations to isolate the variables. Our variables are these. We're going to isolate these. But we're going to start by pulling these negatives out. In order to get rid of these negatives, they're like holes in the ground, right? I need to fill them in. So I would fill them in by putting the opposite. So instead of 3 negatives, I would put 3 positives because they cancel each other out to be 0 pairs. So now they're gone. If I added 3 to this side, I need to add 3 to this side as well of the inequality. Oh, I can put that there. So I did these 0 pairs. They're gone now. That one won't erase, sorry. Ignore those now. Okay, so now I'm looking at 4D's is greater than or equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And now I want to divide all of these D's and into 4 equal parts so that I just have 1D. How much of those 12 does each one of them get if we're sharing fairly? And so 1D will get 3 of the ones. So here, when we do the calculations, right, we end up dividing by 4, which is exactly what we did. And 12 divided by 4 gave us 3. So that, they just wanted our brains to see the model version of what's happening and why. Why am I doing the adding 3 here? Because I'm trying to get those 0 pairs. I'm trying to fill that hole in. So that's why we do the inverse operations. All right, let's go ahead and practice some. Okay, let's take a look at this one. Remember the steps. Distribute, use distribution and combine like terms if necessary. No parentheses, I don't have to worry about distributive property. And on the same side of the inequality, there is not like terms, so I don't need to do that. So skipping that step. Step 2, we will use inverse operations to isolate the variable. Reminder, watch out for any multiplication or division of a negative number during our inverse operations. Okay, we'll keep that in mind. This is very, very similar to when we did equations, two-step equations. It's just that now instead of the equal sign, we're dealing with the alligator. Still kind of picture it as the ocean that we're dealing with. And let's go ahead and start using inverse operations. We want to isolate the variable. These are the two numbers hanging out with the variable. Start by pulling the constant off of there. So this is a positive 7. The inverse, or the opposite of positive 7, is negative 7. We're taking negative 7 away. That makes sense, right? But I have to do that to the other side of the inequality. That leaves me over here with 2x's being greater than 11 minus 7 is 4. Now I have those 2x's, positive 2x's, so I don't have to worry about this step. It's positive, so I'm all right. I didn't worry about the negative here because this was add or subtract, right? It's only when I get to this one where there's either multiply or divide that this comes into play, so keep that in mind. Okay, so I'm going to divide by, this is x being multiplied by 2, so instead I will divide by 2, inverse operation, cancels it out. 2 divided by 2 is 1x. And 4 divided by 2, because I have to do the same to both sides of the inequality, 4 divided by 2 is 2. X would have to be greater than 2. Now, that means that there are a lot of answers. It can be 2, it can be 3, it can be 3.5, it could be 3.75, it could be 100. X could be a lot of answers. So the best way for us to represent what it is without having to list out every possibility forever and ever in our lives is to put it on a number line. So, and I don't want, I don't like to spend a lot of time drawing a number line. So I just take a look at what I've got. I'm going to put 0, my starting point. I'm going to put 2 on there because that's the number I'm dealing with here. And whatever x is, he's not equal to, so I won't color in my circle at 2. If he was equal to, I would color this in. But he is not, so I'm not doing that. It will stay just a circle. And then I'm going to specify whatever x is, he is larger than. So I'm going to say everything this way. Maybe I should do that different color. Everything this way on the number line. 2, 3, 4, 4.5, 5, 5.75, 1,000, 1,000,000. Everything going that way is a possible answer for x. Much rather draw it as a number line than I would as listing out all the possibilities. That would take us for the rest of our lives. So the number line, much, much better. Let's look at another one, including doing the number line. All right, the next inequality that we're given is 5h minus 4 is greater than or equal to 11. So let's have a look at this one. Do I need to do any distribution? Do I see any parentheses that I need to clear out? No. And are there any terms that are like on the same side of the inequality symbol? No, these terms are different, so I can't combine them. And this is only term on his side of the inequality, so I can skip that step. Now we will do inverse operations to isolate the variable. The variable is h. We've got this positive 5 being multiplied him and this negative 4 being subtracted from him. We're going to start by doing an inverse operation to this constant, negative 4. The opposite of negative 4 is positive 4. And if I'm adding 4 to that side of the equation, to keep it balanced, I need to add 4 to this side of the, the inequality. You're going to hear me make that mistake over and over again. The inequality, we're not dealing with equations here. They're just very similar. So here I have negative 4, and then I added 4, which put me at 0. That's why I did that, so that it would go away. And 11 plus 4 is 15. Still doing inverse operations to isolate h, our variable. He's now being multiplied by 5. It's a positive 5, so I'm okay here, so I don't even have to worry about that step. This will stay this direction. So multiply by 5, and the inverse of that is going to be divide by 5. Do the same to the other side of the inequality. 5 divided by 5 is 1, and 15 divided by 5 is 3. Now let's graph that so that we don't have to list out all the possibilities, because whatever h is, it will be larger than or equal to 3. So I'm going to go ahead and put 0. I'm going to put positive 3. I'm going to circle positive 3, and also I'm going to color it in because it can be 3 as well. So that equal to means it can also include 3. And whatever h is, it's bigger because the alligator's trying to get him. It's bigger. So I will just go ahead and color in the bigger side. That's just telling everybody the answer can be any possibility on that number line that is 3 or larger. There's the answer to that one. Let's look at this in terms of a word problem. All right, in this word problem, actually they give us the inequality, but let's take a look at the whole thing. You've been good at translating them already, but there's a key element in here I want to make sure to point out to you. So we have Serena who wants to complete the first 3 miles of a 10-mile run in 45 minutes or less, running at a steady pace. The inequality 10 minus 0.75 p is less than or equal to 7 can be used to find p, the pace in miles per hour, that she can run to reach her goal. Solve the inequality and then graph and interpret the solution. Okay, well, they want us to solve the inequality and graph it. We can do that. I just want to point out to you a couple of things. If we had to translate this one, we're solving for p, so we would say let p, let me write that as 2 separate things. Let p equal her pace. That's what we're trying to find out. And we'll circle the information we know. We know she wants to do the first 3 miles of a 10-mile run in 45 minutes or less, running at a steady pace. Okay, let's draw that picture. She's doing 10 miles. But we're just focusing on the 3 miles of that race for right now. And she wants to do that 3 miles in 45 minutes or less. That means then once she finishes that, we've already done 3 miles. So out of those 10 miles, she will have 7 miles left. So she'll want 7 miles left of it after the 45 minutes. Now, here's our issue we always have to watch out for. Most of our calculations, most of our math are always in a base 10 sort of a system, but time is always tricky because time is a base 60. So 45 minutes is out of 60 minutes, not 45 out of 100 minutes. So we have to make that adjustment anytime we're dealing with math with time. So think of a clock. 60 minutes is the whole trip around, and we'll just turn that into a fraction, right? She wants to do it in 45 minutes. That is, I'll change colors here, 15 minutes, 30 minutes, 45 minutes. That is 3/4 of the clock, right? So instead of 3/4, so we don't have to deal with fractions, you know in money that we split dollars into quarters, right? And if we have 3 quarters, we have 75 cents. That's where that came from, that 0.75 for her pace. So they're taking the whole race and they want to take 45 minutes times the pace that she's running, or 0.75 now in a base 10 scenario. It needs to happen in less than or equal to 7 because she'll have 7 left. So that was kind of a tricky translation on that one because of a few factors. So I suppose that's probably why they gave it to us. But it's a good, if we hadn't broken it down to see that, we wouldn't have caught the little nuances to that. From here, we're just solving it. I do not need to use distributive property here. There's nothing on parentheses. This is my variable here, and this is my constant. So let's start with that. That's a positive 10. So I'm going to go negative 10. This is not a multiply or divide, so I don't have to worry about the weird thing with the flipped inequality. It's just an add or subtract. So I'm taking 10 away from both sides of my equation. This leaves me with 0.75p being less than or equal to, and that's going to end up being a -3 because I have $7. I owe 10. I'll pay 7 of that 10, but I'm still going to owe some. I'm going to owe 3, right? Inverse operation still. This is my variable p. He's being multiplied by a -0.75. Ding, 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 ding. Watch out for that negative because it's going to be divide by -0.75 to both sides of the equation, negative. That flipped my inequality because I divided that negative across. That leaves me with p is greater than or equal to -3 divided by -0.75. Well, a negative divided by negative will be a positive. And then I just need to do 3 divided by 0.75, which should be, let's see, 75 cents plus 75 cents is $1.50, and $1.50 twice is $3. So 0.75 times 4 will give me 3. So P, whatever P is, her pace needs to be more than 4 miles per hour, because pace was in hour. That's why we broke it down to 0.75 hour. So graphed, let me get the color I want for the graph. I would put 0, I would put positive 4. I would circle and include that her pace can be 4 miles an hour to get there in that amount of time, or greater or faster than that. So anything faster than 4 miles per hour, she'd be fine. Let's look at another one. Joshua wants to complete the first mile of a 5-mile run in 10 minutes or less, running at a steady pace. The inequality 5 minus, that's 5-mile run, minus his pace divided by 6 is less than or equal to 4 can be solved to find P, the pace in miles per hour he can run to reach his goal. Solve the inequality and then graph and interpret the solution. So let's go ahead and solve this. We have 5 minus P divided by 6 is less than or equal to 4. Let's talk about where these numbers came from. We have this 5-mile race. That's where this one comes from. We're taking from it the pace that he's running divided by 6. This 6 comes from here. Because pace is in miles per hour, and think about the clock again. In order to, how many groupings of minutes, if he's wanting to do this in 10 minutes, well, let's break that clock down. 10 minutes, 20, 30, 40, 50, 60. So we're dividing that clock into 6. So we're dividing by 6 for the 10 minutes. And that amount minus the 5 miles he's doing will need to be less than or equal to 4. Because the pace is in miles per 1 hour, and that would tell us at least we have 5 miles, and now we've completed one of those miles. There will be 4 left if he goes the pace in miles per hour. It's a little twisty and confusing. I'm sure that's why they provided that, but it's good for us to break that down to see how they got there. Okay, so let's go ahead and use our inverse operations to isolate our variable. This is a positive 5. The inverse, or the opposite of positive 5, is negative 5. This is an add or subtract scenario, so we don't have to worry about flipping our inequality. That cancels. It leaves me with negative P divided by 6 being less than or equal to 4 minus 5 will give me a negative 1, because if I have $4 in my pocket and I owe somebody 5, I'm going to pay 4 of that 5, but I'm still going to owe 1. All right, now this is P being divided by a negative 6. So the inverse of divide by a negative 6 will be to multiply by a negative 6. Ding, 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 watch out. This is that multiplication across that I'm going to do to both sides of the equation with a negative. So that's going to end up getting flipped. So we're multiplying a negative 6 on this side as well. That cancels out and leaves me with P. My inequality symbol gets flipped because I'm having this negative divided by or negative times a negative going on. Negative times negative is positive, and 1 times 6 is 6. Now, I'm ready to graph this on the number line. There's 0. Here is 6. I will circle and I will fill it in because it says it can also be 6. And then I look at my variable P. It's the alligator's going after him, so clearly he's greater than whatever 6 is. So this tells us that Joshua needs to go at least 6 or more miles per hour in order to finish that 5-mile race in 10 minutes. Okay, next example. At Gas and Wash, gasoline sells for $4 a gallon and a car wash costs $12. Harika, well, that's a cool name. Harika, I don't even know if I'm pronouncing it correctly, but it's a cool name, wants to have her car washed and keep her total purchase under $60. Under $60. So this would be the $60 and whatever she's spending, she wants it to be under $60, so smaller than $60. The inequality 4G plus 12 is less than 60 can be used to find G, the number of gallons of gas that she can buy. Determine which, if any, of these values is a solution. All right. One of two ways we can handle this. We can just solve the inequality and find out on the number line if 10, 11, and 12 would fall under that. Or we can just plug these in and play. Before we even do that, I want to go ahead and work on that translation. Even though they did it for us, let's get our brains used to it. So she did, she's paying $4 for every gallon and for gasoline. So $4 times every gallon she puts in. Plus, she's doing the car wash for 12. That's where that came from. But she wants to keep that amount less than $60. All right. So we're looking for G, the number of gallons. If she does 10 gallons, is she under $60? If she does 11 gallons, is she under $60? And if she does $12, is she under 60 gallons? To me, the slowest way would be to say, okay, let me take my equation and I will just plug in G equals 10. 4 times 10 plus 12 less than 60. 40 plus 12, is it less than 60? That's 52. Yes, it's less than 60. Yes. Now let me try that with 11. So now I'm doing the whole calculation again. 44 plus 12, is it less than 60? That is 56. Less than 60? Yes. And then I have to do it again. 4 times 12 now, plus 12 less than 60. That is going to be 12, 24, 36, 48, plus 12 less than 60. 48, 58, 59, 60, less than 60. No. Okay, did I get my answer? Yes. Did I need to do 3 calculations? No, I really could have taken the shortcut and just said, let me just find out what G needs to be. And use my inverse operations. This would take me one set of calculations, and that's it. 60 minus 12 is going to be 48. Divide by 4, divide by 4. G needs to be less than 12 in order for it to be true. And now, once I know that, and I can even put it on a graph for my brain to see it, it can't be 12, but it could be anything that's less than that. Okay, then I just go through. Well, 10 is less than 12. Good. 11 is less than 12. Good. G is 12. No, because it's not equal to 12. So, no, no. So I could have just done the one set of steps once and then evaluated all of those. Or I could have just plugged in the numbers for each one and done all the work. So that's your 2 options, and as you get more comfortable with solving those, that's the option you choose, is to just go, let me just figure out which numbers fit and which ones don't. Look at my number line. That's kind of a sloppy number line. Sorry, it's neater in your book, but we could see it's whatever number's on the number line lower than 12. So anyways, that's everything for this lesson. It does just require lots of practice to get the hang of it, but it is very similar to those 2-step equations, so I think you guys will click to it pretty quickly. The word problems that they give are a little more complex to compared to what you did in lesson 7.2. However, they're giving you the inequality in the word problem itself. Don't just see that and go, never mind, I'm not going to read the inequalities. Since they give it to you, take advantage of trying to reason out how they got that information and how they utilized it without the pressure of having to create it yourself. So take the time to kind of look through it and just make the connections. But know that there's no pressure of you trying to create the inequality. Your goal in this particular lesson is really to practice solving those inequalities. Good luck to you. I know you're going to be great.